Hi, I'm Dave Thomas, and today I am chatting with Ashley Peacock. Ashley, can you introduce yourself?
Yep, I'm Ashley Peacock. I'm a software engineer based out of London in the UK, and I've authored 2 books with the Pragmatic Bookshelf.
And the latest one is?
It's called Serverless Apps on Cloudflare.
Excellent. So Serverless App is something I'm always interested in and never quite have the courage to dive into for real. And I'm wondering if maybe you could help kind of assuage some of my, I don't even know if it's fear. It's just like, I'm not too sure I know 100% what to do. So I guess part of my problem is that in the past, I've always viewed serverless apps as being really just functions that you run. But one of the things I got out of your book is that it's a way bigger ecosystem than that. So, could you talk a bit about how you'd actually go about creating a full app, a full web app, I guess, in a serverless environment?
So I guess if I tackle it from a kind of service agnostic point of view, so if we just don't focus on Cloud for a second, I think there are many different definitions you'll get for serverless, depending who you ask. And one of the ones I think it's from Memento, who have one, and it effectively means that you should pay for what you use. It should scale down to 0. You shouldn't need to maintain anything. So you think about upgrading EC2 instances on AWS, none of that should be required. But the key tenet is that you pay for what you use. So if you use one request, you pay for one request. And in terms of how you arrange them, that very much depends on your application. So in the same way that you have applications that are monolithic in nature, so you have one service that contains all of your business logic. So if you look at Shopify, for example, I think they run like a massive Rails monolith. But you have other companies like Uber who run a microservice architecture where they have maybe hundreds of different services. And the exact same is true for serverless, where although you're probably not going to build a monolith the size of Shopify in a single serverless function, you can certainly build entire APIs in a monolithic serverless function. And similarly, if you really want to, let's say you had an API that had a post, a get, and a delete, you could have 3 different serverless functions for each one. So it depends on your kind of use case of how you want to arrange that, really.
Does the kind of thinking that goes into dividing your app up into microservices also apply to the serverless approach then?
Yes, I would say so. I think though the core kind of mindset you need to have though is really, it's going to depend entirely on your individual use case and what you need to do. With serverless, you're generally less concerned with things like resources. Like you need to keep in mind certain limits, but it should be able to scale up and down as you need, much easier than, say, if you're running EC2, you need to think a lot more about like scaling, for example. Even though you have auto scaling and stuff on AWS, at least with Cloudflare's platform, and even like Lambda on AWS, the number of functions that are needed to serve that traffic will scale to kind of meet demand. But I think good software architecture is needed regardless of serverless, not serverless, monolith or microservices. I think the mindset changes a little bit, like how you approach it, but fundamentally you still need to adhere to good software engineering practice.
That's a good point. So if you were so foolish as to create a monolith serverless architecture, would you be paying a penalty in terms of startup time for the function and things like that?
It's going to depend on provider. So if you are using AWS Lambda, you will generally always have cold starts no matter what you do, unless you use something like provision concurrency, where you're always running at least one instance of your Lambda function, and that way there's no cold start. But then you're not really, it's still serverless, but you're not scaling to 0. You still have that kind of running cost 24/7. With Cloudflare, there are very rarely cold starts. Like you have to try very hard to get a cold start with Cloudflare, because It does effectively while it's doing the TLS handshake. So when your request comes from the client into the server, it needs to do the TLS handshake to make sure that the certificates are all valid and all that kind of stuff that goes on. And while it's doing the handshake, Cloudflare will warm up your worker, which is their implementation of serverless functions. And then by the time that handshake's happened, your worker is ready to serve requests, so that there's no kind of increased latency with Cloudflare. And if you were to stuff everything in there with Lambda, you could probably get away with it because you can scale the memory up to, I think, something like 4 gigs or something. With Cloudflare, they use a different approach. So you are limited to 128 megabytes of memory for each function, which again is not huge. So, but you just need to have certain considerations for building on it. So yeah, just not loading too much into memory. If you're using files, you don't load the whole file into memory, you stream it. But these kind of things are just kind of things I would generally do anyway. But it does mean if you're doing something that does require a lot of memory, it's not the platform for you. But you can obviously...
In a way, though, that constraint is actually a good one because it forces you to think, I think we get into the habit as developers of thinking that resources are kind of free. And, the reality is that's not true.
Yeah, I think there's no reason why you can't, run 90% or 95% if you had a use case where you needed a lot of memory. Run that all on Cloudflare. The front office, for example, can all run on Cloudflare seamlessly. And then if you need something that does do, maybe you need to encode video or something, right? That is going to need more than 128 megs of memory, I would say generally. You use something else like an EC2 instance or something else. You can always mix that in, and there's no reason. It's using the right tool for the job, right? So there's no reason you can't do that.
So you've mentioned Cloudflare a number of times, and your book is pretty much solid Cloudflare. I think some of the techniques you talk about are obviously general, but the actual implementations you're showing are Cloudflare. What is it for you that makes Cloudflare good, and your tool of choice, I guess?
I think there's a few elements that go into it. I think for me, I always want to feel like the platform is kind of working for me and empowering me to do the best job I can, and also to kind of not put barriers in the way. If you take AWS, which is it's obviously a hugely successful platform, it's obviously very technically advanced, and tons of companies are running their entire architecture on AWS. So it's obviously it's not bad, but it's been around for a long time. It's building layer upon layer upon layer of complexity that if you want to do something simple, if you want to connect a Lambda to a database that is running, like a Postgres database and is not serverless, you need VPCs and IP addresses and all sorts of complexity. Whereas with Cloudflare, it feels like they've baked everything you need is kind of offloaded to the platform, which is how it should be. AWS is kind of, I think, tenant, or it's like kind of the principle they ran with is let us do the undifferentiated heavy lifting. And it definitely does do a lot of that. But I think Cloudflare takes that to the kind of next level in the amount of lifting they're doing for you. And secondly, I think the developer experience on Cloudflare is kind of second to none. So if you're building an application, and let's say you need a database, a cache, some queuing, some AI, whatever it might be, all the standard stuff you need to build an application in 2024 or 2025. If you then want to run that locally, you might need to spin up a bunch of Docker containers, worry about different credentials for different environments for local production, staging, and so forth. With Cloudflare, they basically simulate everything locally for you. So every product they have, whether it's databases, caches, queues, etc., it's all possible to run that locally with just running a single command, and they will just handle all that complexity for you. So it just allows you to move really fast. So
they kind of emulate their server environment on your machine as well.
Yeah. So you can, when the worker runs, so again, Cloudflare Worker is effectively a serverless function, very similar to Lambda in design. And if you run that locally, it will run in what's called workerd, which is the runtime that Cloudflare uses, and it's the same runtime that runs in your Chrome browser. So it's using the same technology that Chrome uses, and it's very quick, and that's why it's limited in memory, because obviously your tabs are not using huge amounts of memory. And then when you run your application locally, it will run in the same runtime. So it's very similar to production. And it will emulate, your databases, your caches, everything. And even if you want to run two different workers, for example, locally, when you push them remote, right, they're gonna be able to talk to each other. The exact same happens on your local Mac. It kind of networks them all together, and it just works out of the box.
That is really smart. I like that a lot. One of the things that I've been reading a lot recently about deployment and auto-scaling, and having a look through how to do that with something like Kubernetes. And I got to say, my head is spinning at the amount of configuration and just general knitting that is required to get that to work on, say, AWS. So this is kind of like obviously a bit of a loaded question, but I'm assuming that's not the same if I'm going serverless.
No. So I think even if you were to use AWS, it's going to be magnitudes simpler to run Lambda than it is to run Kubernetes. It's even more true on Cloudflare because you can just run a single command and it will deploy everything for you. If you want a database, you run a single command, it will create your database. If you want a cache, you run a single command, it will create your cache. And then these all are global by default. So if you have used AWS, they have regions. So if you deploy even a Lambda that is serverless, or an EC2 instance or a database, whatever it is, by and large, you are deploying to a region. There are some things that are global, but largely you're deploying to a region. But with Cloudflare, there is no region. So they often refer to it as kind of region Earth, because when you deploy a when you deploy a Cloudflare worker, what happens is they have data centers all over the world in 330 cities. And when your request hits, or an end user of yours hits that Cloudflare worker, it's spun up in the nearest possible location to that end user. So I'm seeing in London, you're seeing in the US. If I was to give you a link to access something deployed to Cloudflare, we would be served from two different data centers, and I haven't had to do anything to configure that. I've just deployed it and Cloudflare has handled the rest. And that is true for the vast majority of their services are deployed kind of globally by default, and the ones that are not, they're working to get them there.
So does that mean things like databases and caches are also distributed, or are they just basically, they choose a location somewhere and they run it?
It varies by product. So if you take caches, for example, that is a globally available cache, and it will be available. It's called KV, and it is available globally. The database is called D1, and it's basically SQLite under the hood. And at the moment, they're not global. They are deployed to a region where you deploy them and you can pick. But coming next year, there are going to be global read replicas, so then your databases will be global. There's things like R2, which is object storage, very similar to S3. That is globally available. And the vast majority of the products are global by default.
Do they run any kind of CDN in front of that?
It depends what you're using. So if you have an API, let's say you implement an API with the Cloudflare worker, it will always hit your Cloudflare worker before it hits any cache. But if your Cloudflare worker is, let's say, retrieving some static content, maybe you need to add some headers to a request, for example, that go back to the end user. You can cache that request, so the next time it needs to fetch that resource, it will be cached. And on top of things like, so far we've only talked about workers. They have a product called Pages, or even now you can do it with workers, where you can deploy your static assets, so your HTML, your CSS, your images, your JavaScript. And obviously you can use all the frameworks that you're kind of familiar with using in the JS ecosystem, whether it's Next.js or Astra or whatever it might be. Any static asset is, first of all, completely free to use. So you can deploy a website completely free to Cloudflare. You're not charged for bandwidth, you're not charged for requests for those assets, and Cloudflare will take care of the caching for you. And you do have control over that caching, so you can amend that caching if you want to, but by default they will take care of all that for you.
So one thing that's worried me about cloud computing in general is vendor lock-in. Like I say, this has nothing to do with Cloudflare. It's the same as true for DigitalOcean and AWS and Google and everybody else. It seems that to some extent, once you've made your decision to go a particular route, then your application is going to be relatively specific to the vendor that you've chosen. Is that fair?
I think I think it's fair. I think whenever you choose anything, there's, like you said, there's always some level of vendor lock-in. I would say for things like if you're using Next.js or Astro or one of the other popular front-end JavaScript frameworks, by and large, when you deploy it to Cloudflare, you're not doing anything special. You're gonna, there's no huge shift in how you build the application. You would do that as you normally would. And for most of them, Cloudflare has an adapter that basically kind of converts it at build time to work on their platform. So it converts it to work with workers and so forth. There's always some level of lock-in because, if you're using a database from Cloudflare or some object storage or whatever, those are, if you want to move away, they're going to need changing. I think the thing I always try and keep in mind is if you abstract that detail away as much as possible with things like, ports and adapters architecture, for example, where you kind of encapsulate any request leaving your application, you wrap it in an adapter that is just, it's making an interface that is translating from whatever you're calling to something internal. So that way, if you need to change it, you're only changing that adapter. And then that at least reduces your vendor lock-in in your code. But normally the vendor lock-in is normally in the data, right? If you have 3 terabytes of data in a Postgres database and you need to move it somewhere else, it's going to be time-consuming, expensive, and difficult because you probably need to serve end users while migrating that data. But yeah, I think some level of vendor lock-in is inevitable.
And also, with, say, Postgres, you may well be using some of their extensions that SQLite doesn't have. That would change your application as well. If we're talking to people who have not yet tried this, what would the sort of like classic hello world be for a serverless app if they want to just give it a go and see what happens?
In terms of Cloudflare, it would be deploying a Cloudflare worker. Cloudflare will do a lot of the scaffolding for you. So if you're familiar with NPM, NPM has create commands where you run npm create and then you give it what you want to create. It could be a React app, it could be whatever. There's lots of them, and Cloudflare has their own one, and it will basically do all the scaffolding for you. So you can pick some options. Like I was mentioning earlier, you can build full stack applications, you can build workers, and you just select what you want from the list. If we were doing the hello world, they even have an option for literally hello world, where they will just make you a nice empty worker that will just return some response. You can then run a command to run the worker locally, and you'd be able to see it in your browser. So in the time it took me to just say those words, you could have created a worker and had it running locally, and even deployed it to Cloudflare probably in the amount of time it took me to explain.
That's pretty cool. Now, would that be an API server or an HTML server?
It could be either. So the platform's going through a little bit of a kind of migration, if you like, where there is a product called Pages, which is specifically made to host not static, but front-end applications, whether it's full stack or static. But they're trying to move everything into workers to simplify it. So released at the end of last year, there's now static asset workers, which do exactly what they say on the tin. They serve static assets, but you can have it serve your static assets and your API in the same one. Because the static assets are just going to be served from Cloudflare separate, kind of. It goes through your worker, but if you want to build, a simple front-end application that also has an API, it's super quick to do with a static asset worker.
Are there any frameworks that exist that handle some of the architectural elements of going serverless?
Specifically on Cloudflare or just generally?
Well, I guess in general, if there is one specific to Cloudflare, that's fine too.
I guess it depends on your definition of architecture, I guess. So if you're looking at AWS Lambda, you have something called AWS SAM, which does a lot of the kind of heavy lifting for deploying serverless applications to AWS. There is the serverless framework, which I don't think it's as popular as it once was, but again, it was effectively a framework that made serverless, in theory, agnostic of a vendor. So you could write, your YAML file with all your definitions in, and then you could deploy it to AWS, or you could deploy it to, Azure or whatever else. So there definitely are some frameworks, but I think it's one of those things where if you make it agnostic, it can also be a bit more difficult to work with than if you just opt for the vendor lock-in and just, full send it if you like.
I can see that. But for things like, say you're used to using database migrations in, say, Rails or something else, am I going to have to do that by hand now?
Well, luckily for you, Cloudflare does migrations for its databases, so you would feel if you come from Rails, you'll feel right at home. Every change to the database is wrapped in migration, and the underlying tooling from Cloudflare will handle all of that for you. So you'd feel right at home in terms of databases. And even if you want to, let's say you don't want to use Cloudflare's database, let's say you do have 3 terabytes of data or hundreds of terabytes of data in AWS, and you're like, well, I have to use AWS, right? I can't move to Cloudflare because I don't want to migrate 100 terabytes of data and so forth. But if you're using a Postgres database, and in next year, I think, MySQL database, there are products from Cloudflare that help you integrate the two. So the one that jumps out is this one called Hyperdrive. The problem with serverless is that if you're connecting to a Postgres DB, you normally have a persistent connection, right? And you might even have a pool of connections. But if your function is constantly being pulled out of memory, and that's what happens with serverless, a request will come in, it will be served by something in memory, and then more often than not, it will be evicted from memory quickly afterwards to help serve other people's requests. You don't want to be connecting to the database every time, because that takes, for Postgres, something like 7 back and forth between the handshakes and all the auth and everything. So it makes it very slow. But with Hyperdrive, it basically keeps your connections pooled. So Cloudflare handle it for you. It will hold those connections to the database. And then when your work needs one, it will just pull it from the pool. And it doesn't have to wait for those, 7 back and forth requests to the database. So there are tools to help you integrate other providers with Cloudflare if you are using other databases. And there are similar things for if your data was on S3. There are tools from Cloudflare where you can migrate your data into their equivalent, or obviously you could just leave it on S3, or they even have tools that will gradually migrate it, almost like a lazy migration, where if you request an object, it will move it into Cloudflare, and then the next time it will just retrieve it from Cloudflare rather than S3. And the really nice thing is that the object storage from Cloudflare called R2 is not entirely S3 compatible, but it implements the same API as S3. So you could even use, I believe, the SDK from AWS, and it will all just work if you just repoint it, for the most part anyway.
So I am in the process of thinking about re-implementing our online system for the bookstore. Would I be crazy to go and just try and do it serverless, having never done it before?
I don't think so. I think the general paradigm is not too crazy to get used to. I think it does require a little mindset shift. Your resources are not always there. You're not always running a server. You need to think about those kind of things and how you're going to segregate your application. And I guess it would be interesting to hear, what kind of traffic patterns do you have? Is it mostly static content? Is there lots of, stuff via API or back-end calls or things, or is it mainly kind of static assets? Because that would change a lot. But I've seen a lot of engineers that I've introduced to Cloudflare, because their developer platform is not hugely well known. If you compare it with AWS, you often hear people be like, "Oh, I thought Cloudflare was a security company or a CDN," which it is by and large. That's their bread and butter. But their developer platform is definitely growing. And of the people that I've kind of shown it to and introduced, they've never struggled to kind of pick it up, because it is really easy to pick up. It's one of those. I think back in the day, if you were doing Ruby and Rails, you would reach for something like Heroku, and everyone was kind of like, "Oh, it's so easy. You just run one command and it's deployed my Rails app." It's very similar to Cloudflare, where it's a really good place for people to start. I think with serverless, or even if you're just starting programming in general and you're learning JavaScript, it's a really good place to just deploy stuff super quick and learn.
And it does sound like they are pragmatic in that they seem to have thought of various developer issues and then found solutions for them, which is nice.
Yes. And pretty much all of their products are used by them internally. So Cloudflare serves something like 20% of the websites in the entire world. So not necessarily from their developer platform, but their CDN and their security product is used by something like 20% of the internet, which obviously requires mammoth amounts of scale and engineering. So the reason that they built a lot of these things was to serve all of this traffic that they're serving, and now they're just exposing it for everyone to use. So it's highly battle tested and used at extreme scales that realistically most of us are not going to have to deal with, because you're not going to have to deal with 20% of the internet for your application, right? It seems very, very unlikely.
One of the things that's always bugged me about AWS is the regions have always felt very fragile, and you keep hearing about the East Coast going down or something. Does the fact that Cloudflare is more granular mean that those things are less significant?
Yes. So while you get performance improvements from serving end users nearer to them, so a worker will be spun up near me if I go and access a website, a worker will be spun up near you if you access it. Let's just say the entire of Europe goes down, for whatever reason, and I access a URL. It's not going to try and go to Europe. It's going to go to Asia, or it's going to go across the pond into America. I think one of the things that I had to work on in my day job was disaster recovery, because I work for quite a large insurance company, and it's an incredibly long and painful process to do disaster recovery if you're region locked to AWS, because the use case for disaster recovery is largely what happens if we lose an entire AWS region. And if everything's deployed to one region and it goes down, that's just game over. So now we are basically deploying to multiple regions. But there was a lot of work that went into that, like huge amounts of work. Whereas with Cloudflare, you basically get that out of the box and for free. I'm not saying there's no considerations whatsoever, but generally speaking, your data is global. Your workers are local, and they're going to handle everything for you. So you get a lot of stuff for free.
So I've read your book a couple of times actually, and one of the things I like about it is the way that you build incrementally, but not just in terms of like your knowledge of the environment, but also the way you add in extra services. Like every couple of chapters will say, okay, now we're going to use R2, or now we're going to use whatever it might be. Is that actually also a way of adopting, getting used to serverless? Is like start off with functions and then add caching, then add whatever else? Or do you think you have to know a fair amount about everything before you can get started?
No, I think there's no reason you can't start with a function, for example, and then, like the simple to-do app, right, is one of the classic ones where you could add a database to keep your storage in, or add some caches. And they're very much like building blocks, They're you could just or it's like going around the supermarket. You just grab it off the shelf and use it there. It really is that easy, because I don't think we've touched on bindings yet, for example, but they're a hugely powerful part of Cloudflare's platform, and that it makes it super easy to integrate these databases, these caches into your applications with very little effort, really.
And in terms of management tools, once you're actually gone live, presumably I have the full range of monitoring that I could need, and observability.
Yeah, they have a dashboard that you would expect from any kind of large provider that gives you insight into the amount of traffic that you're serving, the requests. You can enable like web analytics that will give you kind of not quite Google Analytics level of analytics, but something that's pretty good. You can see kind of what bots are accessing your website, and more commonly, I think last year at the end of this year, they released an AI bot monitoring tool, so you can see which AI bots are scanning your website, which I think is going to become more and more important as the bots are just gobbling up more and more information. You can see who's accessing it and even block it. Cloudflare will literally, if you don't want OpenAI's bot, or you don't want Anthropic's bot coming to your website, you can block them. And funnily enough, in the future, they're going to actually allow it such that not just blocking, you can charge them money. So you can say, look, you can have my content, but it's going to cost you. And we don't know how that's quite going to look yet, but they've raised that they're going to do that, and I assume they're going to have some sort of universal way of doing this that others will probably be able to use. I don't think they're going to do it specific to Cloudflare, but it's an interesting idea, because at the moment they're getting all the information for free, which seems not quite right, and Cloudflare's trying to put a stop to that.
Okay, so you mentioned bindings is something we haven't talked about, so let's talk about it. I'm assuming bindings are a way of knitting things together. What do they actually do for you?
So the primary compute, as we've discussed, is a worker. And a worker on its own is not very, well, it can do a work, but you generally need state and you need other things to build your applications. Database, caches, queues, whatever it might be. And you can create any of those things with a single command and they'll be available instantly. There's no, waiting for an instance to start or anything like that. But then when it comes to using it with your worker, you use what's called a binding. And if you're familiar with dependency injection, it's very similar, but the platform is doing the dependency injection for you at runtime. So let's say a request comes in to your worker. There'll effectively be like an environment, where you have your environment variables, your secrets and everything. But on Cloudflare, you'll also have your bindings. And you can effectively then call methods on that environment variable, and they'll inject a very simple kind of SDK for each one that implements all the methods that you're able to use. So if you think about a cache, it has, you put things in the cache and you get things from the cache and you can list things from the cache. It gives you those methods out of the box. And the nice thing is there's no credentials to manage. So if you're connecting to a database, for example, normally you have to have, secrets and usernames and passwords and hosts. There's none of that. And it will inject the right binding based on different environments. So you can define a staging environment that has a different binding to a production environment. And at runtime, Cloudflare will inject the right one based on the environment. And locally, as I said earlier, these are all emulated. So, you don't change anything local versus remote. You can just run it and Cloudflare will emulate it. And if you really want to, you can do cool stuff like even from your local Mac, you can push your worker remote with a simple command. You just change the flag so it runs remotely, and it pushes it into like a sandbox environment, if you like, on Cloudflare, where your worker is now running on Cloudflare's network, but you hit it from localhost and it hits remote resources. So you can instantly test remote if you want to. And
presumably, is it the bindings then that also talk about your various scaling limits and things?
Not so much. So the bindings purely are to talk to different resources. The scaling is offloaded to the platform. So there are some things you can tweak for things like if you're running, you can run like consumers for a queue, for example, which you can run on Cloudflare, and you have a worker that is your consumer for that queue, and you can limit the number of consumers that run at any one time and things like that. But for workers, Cloudflare generally handles all that for you. And the other cool thing about bindings is we talked about resources, databases, and so forth, but you can also talk to other workers seamlessly. Whereas if you imagine if you're in a microservice architecture, you need to have endpoints like URLs, and you probably need some sort of authentication between them. But with bindings, they're called service bindings because you're talking from one service to another. The networking looks like it's HTTP, but under the hood, they're basically running in the exact same place next to each other, and there's no actual HTTP under the hood. It's all using internal Cloudflare magic to join those two together. And it means that you can I think when you talked about microservices earlier, you can compose these things in a way where normally you have to think about, the fallacies of cloud computing where, the network is not reliable is the classic one, right? This API call might fail. And while there's no guarantees with, anything, the fact that this is not actual networking, this is basically an in-memory call, it means it's incredibly reliable, and you don't have to have the same kind of worry that your API call is going to fail because it's not going over HTTP anymore.
Do you ever get issues, though, that are, because of the dynamic nature of the environment, that are hard to diagnose, like the occasional weird performance glitch if you have a particular set of circumstances? Does that ever happen or not?
It does, but I think you get that with anything, and there are the same tools that you use on any platform to look at things like, whether it's memory or logging, wherever it might be, you can use all those same tools with Cloudflare, who have logging on their platform. So they recently, logging was very much a kind of sore topic for a while, but they now have logs on their own platform, whereas before you had to push them to an external provider. You can now look and query your logs, and I think debugging I don't think it's vastly different to any other provider, really. It's the kind of the bread and butter, if you like.
Cool. So anytime I shouldn't be thinking about something like Cloudflare?
I think there are definitely, use cases, if you need to use a lot of memory, right? It's or even compute, because you pay for what you use, and it's very cost effective. And one of the ways it actually, most applications are going to benefit from a cost point of view is with Cloudflare. You pay for actual CPU cycles. You don't pay for wall time, where wall time is the amount of time your request took. So let's say, these days a lot of apps, they'll call an external API, and or maybe multiple APIs, and maybe those API calls take 2 or 3 seconds each, and you make 2 of them. Normally you would be, on AWS, for example, you'll be charged for the full duration of that request. With Cloudflare, you might only use a millisecond of CPU time, because in terms of CPU cycles, a millisecond is actually quite a lot. And you'll be charged a much lesser amount. So if you think the modern world, what's all the rage? Building apps with AI, and those take a little bit of time, and they all largely involve API calls. So you can rapidly reduce your cost by using Cloudflare, because you're not going to have to wait while those API calls complete. But in terms of things I wouldn't use it for, it is those highly computationally expensive things. If you're encoding video, if you're doing small little video, that's fine. If you need to, encode an entire podcast, you're probably not going to want to do that on Cloudflare. And same for memory. If you need to use up a lot of memory, if you want to run your own AI model, probably not going to be doing that on Cloudflare, for example. But I feel like the way I kind of always talk about it is the vast majority of applications that you build, they're realistically made up of, some front ends, some static content, some APIs, and some storage, some caches, some queues, whatever it might be. It has the kind of bread and butter for the vast majority of applications. So it's rare you can't build most things on Cloudflare. It's more edge cases that I think you have to think about it a bit more.
Well, I think you've inspired me to go away and actually give it a go and see what happens. It has been an absolute pleasure. I've learned a lot, and I'm going to go back and read the book a third time. But I really appreciate you taking the time to talk, Miss, and hope to chat later. So I've been chatting with Ashley Peacock. This is the Pragmatic Bookshop.